I want to spend some time talking about public and private key pairs. And I've noticed that often when I ask a question about how to use a public private key pair, for example, to encrypt email or to digitally sign an email, I'll get an answer that says, will you use the public key or the private key, which seems to indicate that in a lot of people's minds there is only one public key and one private key, and I want to show you that that is not the case. Theoretically, there is an infinite number of public-private key pairs, and mathematically they are not that hard to generate, and the idea is, just like a hash function, it's easy to generate these numbers, and it is very hard to discover or generate one of the numbers if you have the other number. So let's start out by looking at some online public key generators. So I'm just going to do a Google search here. And there's a number of them, and I've used this one before. I can't remember if I've used that one or not. But let's just look at this one. And I have no idea who this Travis Tidwell is. And yours is going to look a little different because I've zoomed my screen or my browser window. So as soon as it loads up here, I've got a private key displayed and a public key displayed, and the key size is 1024 bits. There's a button here to generate a new key, and we'll do that. And it took about a quarter of a second to generate this in this particular application. So here's the key pair. Now recall or remember that this is the private key. The owner of this, or the person that wants to use this, now I guess that would be the owner, is responsible for keeping this private. Under no circumstance do you make a private key public. I get some answers like that from time to time. In no circumstances do you do this. And here's the public key. Now the public key is made public. As a matter of fact, it must be made public or there's no use to have the public-private key pair. Well, I wouldn't exactly say that, because there are applications in Microsoft file encryption where the public-private key pair are used. In both cases, they're both private, but that's just a subset of the possible uses of public and private key encryption. So here we are. This one has 1024 bits. This online application will let you do 2048 or 4096. And just pay attention here. The last part of this, I'm going to make sure that you see that it's going to generate a new key when I click on generate new key. So this is a new key. As a matter of fact, it's longer. And you want to use the longest key that you can that will work with the applications that you're going to use the keys for. Now, the reason is that if someone wanted to discover the composition of your private key, one way of doing that would be to take your public key and a large amount of ciphertext that's been encrypted with your private key, and through code breaking processes and or simple brute force, try to discover what your private key is. Now, this is the kind of thing that the National Security Agency might be interested in doing if you were a high value subject. I'm pretty sure that me personally, I've never done anything that would warrant the National Security Agency to want to try to crack anything that I'm doing. And probably the same goes for you. I'm just telling you the theory behind this. So, if at all possible, use longer keys. And while we're talking about the keys themselves, what you see here, this is an ASCII representation of the 2048 bits in this stream, and these are folded up to display. This is really just one long stream of 1048 bits that's used as a numeric input into the to an encrypting algorithm. Now, just in case I haven't told you this before, these two keys are mathematically connected, such that if you encrypt something with this private key, it can only be decrypted easily, I guess you could say, with the corresponding public key. Now, this is a pair, okay? And again, there are an infinite number of public-private key pairs, but each public and private key in a pair are mathematically connected. So, my public key has nothing to do with your private key. They're two different things. So, use longer keys if you can. And you saw that one, the longer key length took a little over a minute and a half, or excuse me, a second and a half to generate. And this was just one example. We can go back into my search and see if we can find another one here. And I'm just going to pick one kind of random, although I think I've been to this one before. And let's see here. Generate. So you can't see these as well. But this is an RSA private key. And again, this is a stream of ones and zeros, probably just 1024 bits. I don't see a place here to change the number. With these, you can copy these. And of course, you want to make your public key public and keep your private key private. And you might also want to make note here that this is a different public key number or private key number than was generated by the other online application. Now, what I was going to say is you do run into some issues about how to use the public and private keys. So we have this thing called the public-private key infrastructure, and it is the infrastructure's mechanisms to use these public and private keys. So if I'm going to use an online generator, I would have to copy the private key and download it onto my device and then properly encapsulate it so I could use it in other applications. I'd also have to copy the public key and encapsulate it properly so that I could post it, and hopefully we'll look at this later, someplace where everybody can get to it. So with these online generators, there's a lot of things you have to do manually. And also I would say that there's a certain amount of people that would say, well, if you generate the key pair online, how do you know that the private key is, in essence, it would need to be thrown away by the program that generated this after you are through copying it. And certain people would say, well, how do you know that's true? This people, whoever runs this um, application here online might be just collecting private keys. And I have no argument against that. So what you might want to do if you need a public-private key pair is download an application that would do this on your local system. And here is one that does this. This is the PuTTY, or the PUTTY, key generator. Now PuTTY itself is, there's actually a suite of tools here that do some pretty interesting things. The main PuTTY program is a terminal, probably a terminal emulator. It'll let you do things like connect to a Linux box using SSH, or connect to a Cisco router for a terminal session. It's pretty handy. If you've never used it, you ought to investigate what it'll do for you. But it's one of those tools in this suite of tools, and you can simply do a search on PuTTY and get to where you can download this. Better still, do PuTTY key generator. I would download the whole suite of tools myself. You get the key generator in that. But let's see what we can do here. This will do 3 different types, and you've got some control here over the number of bits. I'm going to leave it at 1024 because that's just quicker. So here, notice it says generate a public-private key pair. Notice it says A. Again, there's an infinite number of these. Generate this, and it wants you to generate some randomness by moving your mouse around here. And I think this is kind of the opposite, the idea of if you've ever taken a programming class, you've been introduced to this idea of a pseudo-random number. If you really want a truly random number, it's hard to get it from a computer because most random number generators start with a seed. Now, the theory is here that a random motions of a mouse would generate a unique seed that could not be replicated. So it's just to generate some more secure situation. So here we are. We've got this is the public key here, and notice it doesn't show me the private key. Now it has generated one, and notice the key fingerprint here. This is a hash of the bit pattern here of the key itself. So this is verification, a hash verification, hash fingerprint. Now watch what happens here. There's our public key, and we can save each of these. And if we save the private key, notice it says, are you sure you want to save this key without a passphrase to protect it? Let's say no. What it wants to do here is, this is like a password. Let's use something simple so we can get through this. I'm not that good at typing. So put in a key phrase, key passphrase here. And again, the longer the better. But you need to remember this, because if you forget the passphrase to your private key, it's useless. So now I'm going to say, click on Save Private Key here. And it's going to ask me where I want to put it. And notice it's going to save it as a PPK, PuTTY private key. I don't know if there's any other options here or not. Well, it's going to save it in this particular format. And it looks like I've already saved one. Now that's been encapsulated such that I can move it around. It's protected by a passphrase, and I haven't researched this far enough to see how universally accepted the PPK uh, format is, but I suspect that it's going to work several places. Same thing with the public key. Now, if you click on Save Public Key here, you're going to get the same process. I can't show it to you right now because of privacy issues when it opens up the default location. Probably need to do a little research here to see what kind of format this is going to be in. But PuTTY is an example of a locally run public-private key generator. And just to review, you're going to need to be able to encapsulate your public key in a form that you can post it. And I intend to make a video on what you can do with your public key after you generate it. And by the way, you can have more than one public key. You just have to be able to manage this. And it could conceivably get complicated if you're trying to, if there's more than one public key for you out there, someone's trying to communicate with you, how they're going to know which one to get. But theoretically it's possible. And you have to deal with your public key, and you also have to deal with your private key. And PuTTY here allows you to use a key phrase to protect it. So what I wanted you to see here is that there are an infinite number of public-private key pairs. It's not hard to generate a public-private key pair using what are obviously computer programs, but the idea is that these are long enough, and remember, these are just streams of ones and zeros, and in this case this is being displayed as the ASCII equivalent of a stream of ones and zeros. So longer keys are better, and once you generate a public-private key pair, you've got to somehow manage these. The public key needs to be made public. We'll talk about that later. Private key must remain private, and in a form where it can be used in various applications. So the big point here is there are an infinite number of public-private key pairs, and they're not hard to generate, and they're very useful actually.